Right now, there is enough ice on this planet to bury every skyscraper on Earth underwater. Not flood them, bury them. And if every glacier, ice sheet, and frozen shelf melted in a single night, most of you would wake up to an ocean where your city used to be. This isn't science fiction. This is basic physics. And what happens next is stranger, faster, and scarier than you think. Let's start with the numbers, because they matter. Earth is holding about 26 million cubic kilometers of ice. Antarctica alone holds enough to raise sea levels by 58 meters. Greenland adds another 7. Every mountain glacier on the planet adds a little more. Now imagine it's all gone, overnight. In the first hour, nothing looks different yet. Water takes time to move even during a global catastrophe. But under the surface, something violent is already happening. Ice shelves the size of countries are collapsing into the sea at once, sending shockwaves through the ocean. Coastal regions near Antarctica and Greenland get hit first, not by rising tides, but by surges, walls of displaced water slamming into shorelines like a slow-motion tsunami. And here's something almost nobody knows. Melting that much ice at once doesn't just raise sea levels. It changes how fast the Earth spins. Mass is shifting from the poles toward the equator, and that alone can measurably slow down the length of a day. Scientists have already detected this happening in tiny amounts today, from normal glacier melt. Now imagine it happening all at once. By the end of day 1, the real disaster begins. Sea levels don't rise gently. They rise in surges because ice sheets don't melt evenly. They collapse in chunks, each one displacing enormous volumes of water instantly. Coastal cities, New York, Mumbai, Shanghai, London, Jakarta, start losing streets, then blocks, then entire districts within hours. There is no time to evacuate everyone. Roads flood before cars can leave them. Airports, many built near coastlines for easy access, disappear first. Emergency systems built for storms lasting days are suddenly facing a disaster that has no endpoint, no eye of the storm to wait out. And here's the part that catches even scientists off guard. Floating sea ice, like the ice covering the Arctic Ocean, doesn't raise sea levels when it melts. It's already floating, like ice cubes in a glass of water. But losing it changes something else entirely. Ice reflects sunlight back into space. Without it, the dark ocean underneath absorbs far more heat. The planet doesn't just flood, it starts heating up faster, immediately, as if a global sunshade had been ripped away in a single day. By the first week, the ocean itself starts to break. All that melted ice isn't salty, it's freshwater, and suddenly there's an unimaginable amount of it pouring into the Atlantic and Pacific. This disrupts something called ocean circulation, the deep currents that move warm and cold water around the entire planet, like Earth's circulatory system. One current in particular is critical, the one responsible for keeping Western Europe far warmer than its latitude should allow. Flood it with enough fresh water and it can stall, slow down, even collapse. Here's the twist. Almost nobody expects, while the rest of the planet heats up from lost ice and lost reflectivity, parts of Europe could actually plunge into extreme cold. Not gradual cooling, a sudden climate whiplash, all triggered by the very same event that's flooding the coasts. Warming and freezing, happening on the same planet in the same week because of the same disaster. Meanwhile, storms are intensifying. Warmer oceans mean more energy for hurricanes and typhoons, and they're now forming in places that historically never saw them. By the first month, a quieter crisis becomes impossible to ignore. Fresh water is disappearing. It sounds backwards, doesn't it? The planet just flooded, and now there's a water shortage? But almost 2 billion people depend on glacier-fed rivers for drinking water and farming. Rivers like the Ganges, the Indus, the Mekong, the Colorado. These rivers exist because glaciers slowly, steadily release meltwater all year, especially during dry seasons. If the ice is simply gone, that steady supply disappears with it. The rivers that fence some of the largest farming regions on Earth begin to run dry or become unpredictable, right as coastal farmland is underwater and global food supply chains are collapsing. This is the cruel irony of a world drowning in water. The flooding creates disaster in one place, while the sudden loss of glaciers creates drought and famine in another. Both are happening at the same time, on the same planet, from the same cause. Now zoom out. Months become years. The coastlines we grew up memorizing are gone, redrawn permanently. Florida, Bangladesh, the Netherlands, most Pacific island nations, largely underwater. Hundreds of millions of people become climate refugees, the largest forced migration in human history, all happening at once instead of over generations. The land itself starts to change too. In places where massive ice sheets used to press down on the Earth's crust like a giant weight, the ground slowly begins to rise now that the weight is gone. A process that takes centuries, but that scientists can already measure happening today in places like Scandinavia and Alaska. And there's one more hidden danger buried inside the ice: ancient organic material, and in some cases, ancient microbes, trapped and frozen for tens of thousands of years. As permafrost and glacial ice melt, some of this material releases methane, a greenhouse gas far more powerful than carbon dioxide in the short term. That means even after the initial flooding stops, the planet keeps warming, fueled by gases the ice had been locking away all along. The world that emerges isn't just wetter, it's a completely different planet. New coastlines, disrupted currents, unpredictable weather patterns that no longer match anything in recorded history. Here's the unsettling truth. Nothing about this happens overnight in real life. It happens over decades, sometimes centuries. But every mechanism we just walked through, the rising seas, the collapsing currents, the vanishing rivers, the released methane, is already happening today, just slower. We're not describing a fantasy. We're describing a preview, running in slow motion, right now, in real time. So here's the question we're sitting with. If watching it happen in a single night would terrify all of us into action, why does watching it happen slowly make it so easy to ignore?